Today I'm going to talk about LeetCode question number 1448, count good nodes in binary tree. Given a binary tree root, a node x in the tree is named good if in the path from root to x there are no nodes with a value greater than x. To the number of good nodes in the binary tree. Okay, so let's say we have x here. So in the path between root and x is a good node if no other nodes along this path is greater than x. Okay, so in this path we have the values 3 and then 1. Now obviously 3 is greater than 1, so this is not a good node. Okay, now let's look at this path. Okay, so in this path we have 3 and 1 and 3. So obviously the root is always going to be the good node. Okay, and so we've seen 3 so far, and what about 1? This node is not a good node because we've seen the node 3 already, value 3, and that means it's greater than x, which is what 1 is right now, it's x, 3 greater 1, so this is not a good node. And then here, this is obviously greater than 1, so this is the current x. So this is obviously greater than 1 and equal to 3, so therefore it is a good node. Okay. And similarly, in this path here, like let's say this is node x in this path here. So we have 3, which is obviously the root is always going to be a good node. And 4, what other value nodes have we seen? Well, we've only seen 3 so far. Okay. So 3 is less than 4, so therefore this is a good node. And what about this guy? This value 1, what other nodes have we seen so far? We've seen 4 so far. We've also seen 3 so far, but 4 is good enough to compare against, okay? So therefore this is not a good node. And finally, this last path here, 3, 4, 5, obviously this is a good node, and this is a good node, and this is a good node because the previous nodes that we've seen are of lesser value than 5. Okay, so therefore this is a good node. So how do we go about this? Do we have to store all the nodes that we've seen in a path so far? Like if this is x, do we have to store 3 and then 4, and then by the time we get to 1, do we have to compare both of these? Well, we don't have to compare both of them. We only have to compare against the largest value we've seen so far in this path. Okay? Only the largest value we've seen so far, that matters. Okay? So if like this is 0, obviously this is a good node. This is also a good node, 4 is greater than 0. Is this a good node? No, it's still not, because traversing this path to get to 1, we've already seen 4, this large node here. We don't compare against 0 now. We compare against the largest we've seen so far, and so far the largest we've seen is 4. Therefore, it's greater than x here, greater than 1, so this is not a good path. So basically, instead of keeping track of all the nodes we've seen in the path, we only have to keep track of the largest node we've seen so far while traveling through a path. And this is how we're basically going to go about it. Okay. So it's basically going to be regular depth first search traversal of the tree with the slight twist that we have to keep track of the largest node we've seen in a path. Okay, and also keep track of a number of good nodes. Yeah, and that's how we're going to go about this. This is going to be O of n time. And yeah. Okay, now to code this up. So first off, what I'm going to do is handle an edge case where if root is none, then return 0. Okay, obviously if the tree doesn't exist and there are 0 good nodes. And then what I'm going to do is initialize my results variable. Yeah, I'm going to use this in the recursive call here, in my recursive helper function here. I'm just going to store my number of good nodes in this global result variable. I just find it easier this way. Also, what we're going to pass in is max so far. Okay, so what we're also going to pass in this recursive function helper is the node and the max node we've seen so far while we're traversing this path. So obviously, if we're first calling this function, obviously this node here would initially be the root node, and max so far would be the root dot value. But as we traverse down the tree, we're gonna be updating this max so far variable if we see a node greater than the max so far. Okay. So my base case would be if root is none, then it's return. Else, current max is gonna be the maximum of root so far and the current node. Okay, this is our current max so far. And what we're gonna do is, so this is max so far we've seen along the path, and current max simply updates it. Yeah, just in case, if we have like, 3, 4, or like 10, 9. Now we see max so far is just going to stay 10. If we have 3, 4, max so far is going to be 4. Or current max is going to be 4. So, okay, root dot val is greater than or equal to the current max. Then update result. Yeah, okay. Otherwise, if the current root's value is less than our current max, then it's not a good node. Like for example here, current max would be 3, and the root and our node here would be 1. So obviously 1 is not greater than or equal to 3, so this doesn't get updated. And then after that, we're going to make our recursive calls. Yeah, we're going to make our recursive calls here and just continue traveling down the path. Okay. So this is a basic preorder traversal. Finally, we're going to do is call helper. And then return result. Return. Okay. So I'll try compiling it. Max so far, not root so far. Okay, I'll try again. Okay, great. I'll try submitting. Okay, awesome. Thanks for watching.